Welcome to a webcast produced by the Learning Enhancement team, based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Trigonometry series and concerns Pythagoras' Theorem. This guide introduces a fundamental part of trigonometry, Pythagoras' Theorem. It illustrates how Pythagoras' Theorem is used to solve problems involving right-angled triangles. Introduction and History. Pythagoras of Samos was thought to be an Ionian Greek mathematician and philosopher who lived around 500 BC. His work and teachings gained him a group of disciples who, together with Pythagoras himself, developed and formalised a range of ideas which are still studied today. The most famous idea attributed to Pythagoras is a geometrical theorem which relates the lengths of the sides of right-angled triangles. A right-angled triangle is an angle with the sides of precisely 90 degrees. Right-angled triangles are extremely common in mathematics. They appear not only in trigonometry but also in vectors, complex numbers, geometry and many other mathematical disciplines. There are also many problems in science that can be modelled using right-angled triangles. Pythagoras' theorem plays an important role in being able to solve these problems. Pythagoras' theorem. Let's start by drawing a right-angled triangle. It is customary to assign lowercase letters a, b and c to the side lengths. The longest side is usually labelled c and is called the hypotenuse. It is always opposite the right angle, which is indicated by a small square. For any such right-angled triangle, the following theorem always applies. A squared plus b squared equals c squared. This is known as Pythagoras' theorem. Pythagoras' theorem is useful as you can calculate the length of one side of a right-angled triangle if you know the lengths of the other two. A good tip is to identify c for your triangle first. This enables you to substitute the two known lengths into Pythagoras' theorem correctly. Remember that c is always the longest side, the side opposite the right angle, and the two shorter sides are a and b. It does not matter which is which. There are certain triangles in which a, b and c take the value of whole numbers. These are special cases of Pythagoras' theorem and are called Pythagorean triples. More commonly, your triangle will not have all three sides with lengths which are whole numbers. When calculating lengths, you should give your answer to a small number of decimal places, 1 or 2, and state this as part of your answer. Pythagoras' theorem is often stated in the following way, which might make it easier for you to remember. In a right-angled triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. This concept is represented by the following diagram. The area a squared, the length of the side a is 3, and the area a squared is 3 times 3, which is 9. The length of the side b is 4, so b squared is equal to 4 times 4, which is 16. If you add 9 and 16 together, you get 25, which is indeed equal to c squared. So the numbers 3, 4 and 5 form a Pythagorean triple. Let's do an example. Let's find the length of the hypotenuse of a right-angled triangle with side lengths 6 and 8. Firstly, the question states that you are interested in a right-angled triangle, and so Pythagoras' theorem can be applied. The question also states that you are trying to find the hypotenuse, which implies that 6 and 8 must be the lengths of the two shortest sides. As with all trigonometry problems, it is useful to represent the problem as a diagram. Let's start with a basic right-angled triangle. As 6 and 8 are the two shortest sides, i.e. a and b, this triangle becomes where we have replaced a with 6 and b with 8. So you substitute into Pythagoras' theorem and proceed as follows. Firstly, State Pythagoras' theorem. A squared plus b squared equals c squared. Next, substitute a equals 6 and b equals 8. So we have 6 squared plus 8 squared equals c squared. Next we perform the squaring. 6 squared is 36 and 8 squared is 64. Add the two numbers together. 36 plus 64 is 100, which is equal to c squared. And then take the square root. So the square root of 100 is equal to c. Now we write the answer. Note that the square root of 100 is equal to plus or minus 10. However, the minus option is nonsensical, as you cannot have a negative length, and so you take the positive value. Let's do a more complicated example. The two longest sides of a right-angled triangle are 2.9 centimetres and 3.4 centimetres. Calculate the shortest side. Again, you can use Pythagoras' theorem because you are dealing with a right-angled triangle. In this case, however, you are given the hypotenuse and the second longest side, meaning that you have to work out the shortest side, or A. Again, let's start by drawing a basic right-angled triangle. So this becomes, as C, the hypotenuse, is 3.4 centimetres, and B, the next longest side, is 2.9 centimetres. You can now follow the same technique as above. Substitute the known lengths into the theorem and then simplify, rearrange and solve in order to calculate the length A. Firstly, state Pythagoras' theorem. A squared plus b squared equals c squared. Substitute. B equals 2.9 and c is equal to 3.4. So a squared plus 2.9 squared equals 3.4 squared. Perform the squaring. 2.9 squared is 8.41 and 3.4 squared is 11.56. Next, subtract 8.41 from each side. So a squared equals 11.56 minus 8.41, which is 3.15. Take the square root. So a is equal to the square root of 3.15. And finally write the answer to two decimal places. So A is equal to 1.77 centimetres to two decimal places. Further guidance and information. If you have any further questions about trigonometry or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.